Hi, here I wanted to talk to you about variable measurement, also referred to as types of variables. And there are different ways to think about variable measurements, but generally they all follow along with something like this. There are essentially quantitative variables, quantitative ways to measure something in the world, and also qualitative, so categorical, often also called qualitative. And the quantitative measurement, are the continuous variables and discrete variables. So essentially, these are integers, things like one or two or three, where the variable, the values have to be an integer, and continuous can be decimal points, 2.5, 3.6, for example. How much did it cost? Well, it cost $2.5, and so on. Within the categorical variables, we have a nominal and ordinal. Now, the thing is, ordinal has a kind of quantitative component to it, whereas nominal has no quantitative component to it. And actually, we're going to explore some of these variable measurements also in some other terms here. So another way to view variable measurement and with some examples are the following. First is the nominal. So that's a qualitative variable and which may have values here as an example. Color would be the variable, and then red, blue, and white would be the potential values for that variable. And these values are nominal, so we call this variable nominal. Ordinal. Ordinal is a semi-quantitative variable. So they include categories, but there is some descending or ascending order. So for example, flight technique, where the values are poor, okay, or good, can be an ordinal variable because there's some order between these here. Interval. Interval is a quantitative measure with possible quantitative differences between values and often associated with discrete or integers. So for example, year observed, 2010, 2011, 2013, these are numbers. It's a quantitative variable which can be calculated. So you can say 2013 minus 2010. However, the difference between interval and the ratio, which is actually not exemplified in this diagram here from our textbook, is that the interval doesn't have a true zero. So for example, year 0 doesn't mean no year at all. It just means a year that we counted as 0. And the same as, for example, temperature. Temperature, if it's 0 degrees, doesn't mean no temperature. In other instances, in the ratio kind of variable, is the variable that does have a true 0. So for example, years of age, there's 0 years of age, 0.5, 1, and so on. So this can be decimal as well. This is another way to think about variable measurement, very common in statistical education. And also we have to think about data type. So usually they kind of go hand in hand, but data type is how the computer organizes the information. Whereas these other terms we were using before is more about the statistical thinking. So a nominal category, a nominal variable often is going to be represented by data type as text, character, or string. And often these are kind of the same data type. It just depends what kind of platform or program you're using. So generally, categorical variable, the values are going to be in this data type. And then therefore, the variable is also going to be all in that data type because usually a variable only has one data type. Ordinal can be recorded in data type as text, character, or string, actually. So if we were to record it as, for example, flight technique is a variable, flight technique of the bees. And then we have 3 separate values, poor, okay, or good. Well, we can record it in data type as text, also called character, and so on. Or we could also record it as integer, which is a different data type than text or character. And the values could be -1, 0, or 1. Poor, okay, and good. Interval often is going to be represented by integer, but I think in some cases it could be represented by decimal, where the values have a decimal point. And the ratio usually is going to be represented by data type decimal, sometimes called double or float, once again, depending on the programming or platform you're using. So these are the data types or data structures. And usually these are the native data structures of computer programs: integer, decimal, and character. And also, of course, lastly, perhaps the most important or interesting one is binary. So that's the measure that has two values, or one or two potential values: presence or absence, or true or false. So is the animal that you're studying carnivore? Yes or no? That could be a binary variable. And the data type in the computer, well, it's going to be binary, which is, of course, the most native data type of computer. Binary data is actually interesting and special because any number or category may be translated into binary, which is numerical, right? Binary is numerical in the sense that it's 0 or 1. Generally, we're not going to translate a numeric variable into binary. So, for example, does the animal have more than 2 wings? True or false? That could be useful in some cases, in some studies, depending on the context. But generally, if we have a numeric data, we'll keep that because it has more information, right? So instead of more than 2 wings, we would just have wings, number of wings. And instead of binary, the value here would be, 1 or 2, maybe integer, or 3, and so on. Now, other categorical variables, for example, can be translated into binary. So think about male. Male, true or false? So, or 1 or 0. So male is a nominal or categorical variable. However, because male is, and gender is a category, but we could translate that variable into a kind of binary data type, so we can make mathematical calculations with it. So if the one B is a male, you write 1. If another B is a female, you write 0 for this variable, and so on. Another important notion when we're dealing with variables are the variable associations. So there are two major associations, which is positive association or negative association. We kind of should address here, we're talking about linear association. Positive linear association, negative linear association, of course, no association as well. So there's some examples from the book here. We have two variables. One variable is median household income on the x-axis, and as always, to the right goes up. So that's thousands of dollars, 50,000, 100,000. Here goes up. And then on the y-axis, we have population change over 7 years. So let's just think about it as growth in population. So the idea is, as median household income goes up, does the population also go up, or does it go down? Question, what's the observational unit? Well, in this case, it could be various things. It could be countries, it could be cities, it could be towns. It's not going to be a person, but it has to be some kind of community. And actually here, it kind of shows a positive association. A little bit looks like, as one is going up, as the median household income is going up, the population is also going up. But it's kind of weak. Now, we have another positive association. Actually, it would be nice to have a negative association, but these two examples are kind of positive. Here we see the Gini coefficient, which is a measure of inequality. So the higher the number as it goes to the right, the higher the inequality. The observational unit are countries. And on the y-axis here, we have risk of theft in business, so business corruption. And apparently the data in this case here shows that if the country has higher inequality, there's a trend that they're also going to have more business corruption. But these, we have to remember, these are positive or negative associations, and association not necessarily equal causation. And also, very importantly, as I'm going to mention, we need to think of which variable is causing what when we're thinking about this. So is the business corruption creating more inequality in the country? It's actually conceivable in that sense, right? The more corruption, then resources are not distributed fairly or justly, and then leads to more inequality. But we can also think the other way. We can think that as a society has a growing inequality, and by inequality, we're talking about economic inequality, then the social fabric starts to fall apart and people feel like it's more okay to engage in corruption. And so these are the notions here of explanatory variable and response variable. So the explanatory variable, also called independent variables or predictor variables, are the ones that we thinking are doing the cause or the influencing. And the response variables are the ones that we think are being impacted or influenced, also called dependent variable and outcome variable. So that's it for this one. We'll have more next time.